Welcome back to a new machine learning tutorial. In this video, we are going to talk about stacking regressor. We are going to talk about the theory behind the algorithm, and then we are going to code it using Python. Let's start coding. I will be using Visual Studio Code as the code editor in this tutorial, but you can use any code editor that you want. I'm going to create a file named stacking regressor, and it's going to be a Jupyter notebook. Next up, I'm going to select my kernel from here, 3.11.4, and I will say stacking regressor. And now we are going to talk about the concept. This is an ensemble learning technique that combines multiple regression models to improve predictive performance. The concept is really simple. Several base models like Model 1, Model 2, Model 3 are trained on the same dataset, and the predictions are used as inputs to final meta model. So we are going to get predictions from that, and we will say prediction 3, and we are going to use meta model, which is going to be trained with these predictions. We are going to train different models, we are going to get predictions, and we are going to create a final model using these predictions. And this process helps reduce overfitting and improves generalization by leveraging the strengths of each model. So we have two layers, base layer and meta layer, and we can name this as level 0. And this consists of multiple base models trained on the original dataset. And the meta layer, we can say level 1. After the base models have made their predictions, these predictions become the input to a meta model, which is trained to predict the final target variable. So let's start coding. Firstly, I will say from Scikit-Learn.datasets import make regression for data creation. And next up, I will say import numpy as MP. And I'm going to create my regression dataset using x, y. I will call make regression method. I'm going to give number of samples as 1000. I'm going to add, let's say, 10 features. Next up, I'm going to say noise is going to be 5. So I'm going to create my data like this, and my x matrix is going to be looking like this, and y vector is going to be looking like this. So we have a regression problem in this way, and I'm going to call x shape with y shape. We can see that we have 10 features in this side and we have a vector in this side for the y. Okay, so for the level 0, we need to define base models. These models will be trained separately and their predictions will be used as input for the final estimator. We will use different models like I'm planning random forest regressor, ridge, and k-neighbors regressor as base models for diversity. So I'm going to start with random forest from Scikit-Learn.ensemble import random forest regressor. Next up, I will say from Scikit-Learn.linear model import ridge. And I'm going to say from Scikit-Learn.neighbors import k-neighbors regressor. And I'm going to define the base models like base models is going to be equal to the random forest at the first place. We can say like random forest, and it's going to be a tuple. So I'm going to say random forest regressor. Next up, I'm going to define ridge. So I will say ridge, and I'm going to set the ridge like this, ridge regression. Next up, I'm going to set KNN, so I will say k-neighbors regressor. I'm going to call that on here. So our base models are ready right now. Next, it's time for the meta model. So for the meta model side, I'm going to use support vector regressor. So I will say from scikit-learn.svm support vector machines import svr, which stands for support vector regressor. And I'm going to call meta model, and it's going to be equal to the svr, and I'm going to set my kernel. Actually, let's not specify any parameters. We are going to talk about hyperparameter tuning lately, so I'm not going to be passing any parameters. And we set our meta model right now. Next up, we are going to create the stacking regressor. For that, we are going to make some imports. We will say from scikit-learn.ensemble import stacking regressor. Next up, we will say, actually we can do the imports together. We will say from scikit-learn.model selection import train test split, and we will say from scikit-learn.matrix import mean squared error. So we have our imports ready right now, And the next step is going to be splitting the data into training and testing sets. And if you want to learn more about the machine learning concepts like train test split, or for the Scikit-Learn metrics, the model evaluation side, you can check my machine learning tutorials playlist, where I have more than 40 tutorials just like this one. I'm going to be added that machine learning tutorial playlist in the description and in the cards of this video. So we can type, like, let's say machine learning tutorials playlist in description and cards. So let's do train test split. I will say X train, and I will say X test, Y train, Y test, and it's going to be equal to the train test split. I will pass X, Y, and test size is going to be 0.2, which means that 20% of the data is going to be in the testing set and the 80% is going to be in the training set. Next up, we are going to set our stacking regressor. So I will say stacking regressor. It's going to be equal to stacking regressor like this. And at the estimator side, we are going to give the base models we have. We define them in here. And next, for the final estimator, we are going to give meta model. Like final estimator is going to be the meta model. So after setting this, I will say stacking regressor that fit X train with Y train. And now we can make predictions with the model we train. I will say stacking regressor that predict, and I will use X test, and we can get values like this. Next up, I'm going to set them in something like Y predictions, and I'm going to say mean squared error. I will call Y test with Y prediction. So this is the mean squared error value that we have right now. Now we can do hyperparameter tuning. Again, you can check my machine learning tutorials playlist for learning more about the concepts. And we can tune the hyperparameters of both the base models and the meta model. For this, we will use grid search. So I will say from Scikit-Learn .model selection, import grid search. And we are going to do hyperparameter tuning for improving the model performance. And we want mean squared error to be lower. So if we can lower this mean squared error value, then our operation is going to be successful. So I will say parameter grid. I'm going to define something like, let's say random forest number of estimators, and I'm going to pass 50 with 100. Next up, I will say ridge alpha, and I'm going to say 0.1 and 1 like this. Next up, I will say KNN. By the way, you can extend these values in the way that you want. Neighbors, I will say 3 and 5. Next, I will say final estimator C, and it's going to take values like 0.1, and I'm going to add 1 like this. I'm not adding too much values because I want it to run fast, but you can extend these lists. More values you try, the better chance to get a better model, but at the same time more computational costs. So I will say scale and auto in here. Next, I'm going to set my grid search, like I will say grid search, and it's going to be equal to the grid search cross-validation. Estimator is going to be equal to stacking regressor, and parameter grid is going to be parameter grid I defined. I'm going to set cross-validation as 5, and scoring is going to be negative mean squared error, because lower value perform better. The lower the mean squared value we have, the better the model. So I'm going to set it, and I'm going to start training it using grid search.fit X train with Y train. So it raised an error. Let me quickly check the error message. Okay, I made a typo. I'm going to fix that quickly. Yes, I'm missing a T in here. So I'm going to be making them all run again. And now it's training. I'm going to be re-recording when this finishes. It's finished in 2 minutes and 29 seconds. Now we can reach the best parameters using best parameters. And they are 5 for the number of neighbors of the KNN, 100 for the number of estimators, 0.1 for reads alpha, 1 for the C for the SVR, and scale for the gamma. And now we are going to make predictions using grid search tuned model, which is best estimator, and we will say .predict. And we are going to pass the X test in here. Let's store them in something like y prediction tuned, and next up I'm going to call the mean squared error. I'm going to call the y test with y prediction tuned in here. So our new mean squared error is 1095. Let's check the last one. In the base model side, I'm searching it. It was 3391, so we improved our model's performance by doing parameter tuning. Great! Let's summarize what we did in this video. We talked about the stacking regressor, the logic behind that, and base layer with meta layer. Then we create our dataset in here. I showed you the shapes of the data. Next up, we defined our base models and meta model. Next, we applied train test split for getting training and testing sets, and we set our stacking regressor. We trained our model with base models, then made estimation with the meta model, and we make predictions with the stacking regressor in here, and our mean squared error is 3391. Next up, we set grid search and we defined possible parameters. You can extend these lists once again, and we initialize the grid search. We train the grid search. Next, we check the best parameters found from the trained models on grid search, and we make predictions with the grid search best estimator that predict, and we check the mean squared error, and it's 1100. So our hyperparameter tuning process improved the model's performance on predicting. That's it for the coding part. Let's get to the outro. Thanks for watching this tutorial on stacking regressor. I'm sharing new data science videos every week on my channel. You can subscribe for more videos like this. Also, I have a machine learning tutorials playlist where I have more than 40 videos just like this one. You can reach that playlist from the cards of this video. Have a great day.